Good day. Significant digits and measurement. This is the second part of it, so we're going to go to the back of the page or the next page. And here it simply goes and it talks quite a bit about the importance of significant digits. In any measurement we do, the measured value can never be considered exact. There's always uncertainty in a measurement. So any measurement, there's always uncertainty because let's say I use a ruler and I can measure the nearest 100th centimeter. Well, then we come up with a ruler that can measure the nearest 1,000th, and then someone comes up with the nearest 10,000. And we can keep going like that, essentially forever. So when we do a measurement, the significant digits are really telling the reader how precise we were about doing the measurement. So that's where it talks about reflexive precision. And later on, we'll be doing calculations involving those. And that means you have to have a total understanding of what significant digits communicate. Here we have an example. This is going to be leading into our next video and set of notes where we do calculations involving significant digits. And so here we have 4 objects, and 32.45, 52.2, 68.29, and 6,000. And a math person is just going to go and just add them together and say, hey, we got this. But a scientist, particularly a fantastic chemist, is going to say that's a crock. Because we have no idea, but it looks like this measurement, the 4th measurement, was done to the nearest 1,000 grams, maybe nearest 500 grams. So it's somewhere between 5,500 and 6,500 grams. So taking a very imprecise measurement and getting more precise measurements and adding them together to get a very precise thing doesn't make sense. In fact, we're going to be limited by our least precise measurement. And that, in this case, is this beast. So if we actually went through, and according to the laws of chemistry and physics and science in general, if we add 6,000 plus these 3 measurements, we're going to actually get 6,000 grams. And that's just the way it is. Get used to it. We're going to shake up your view of math. It's going to be great fun. But anyways, whenever it's unclear about the number of significant digits in a measurement, you can always make it clear by putting it in scientific notation. If you don't know how to use scientific notation on your calculator, pay close attention. Because every year I get people who use the wrong buttons on their calculator and their answers are off by a factor of 10 every time. So it is hugely important that you pay attention. And we look at this. What are a number of sig figs in precision measurement? 20,000 kilograms. Not a great measurement. Likely we're looking at 1 sig fig, and likely we're looking at nearest 10,000 or nearest 5,000 kilograms. So that would be a sloppy measurement. Might be fine for circumstance, but from a science point of view, pretty sloppy. And there it is, chemists usually. Civilized, polite, pleasant, Boston Bruins fans. Alrighty.